Oh, it's important you do that so that you can have
Okay.
a full understanding of concepts and topics we covered yesterday.
I'll do
Okay.
that. Yeah, I'll do that.
All right. So we are an organization that is very keen on time management. And just like we said, every training starts by 8 p.m. So without wasting much time, we have Sheyi here. So, but I will want him to do the introduction, just like we always do. Introduction is always very, very important
Okay.
for everyone here. So, I'm going to do a brief introduction about myself. So, my name is Tim Tokwe, and I'm the team lead of Blockchain Labs. You know, this is where we train people and we onboard them to Web3 through our trainings and things that we do. So, and I'm going to hand over to Sheyi now to introduce himself too.
Hi, my name is Sheyi, and I'm the technical lead at Blockchain Labs.
All
Okay.
right. So thank you so much, Sheyi, for that. So, Sarah, we also love to meet you. You know, just tell us your
Okay.
name and what you do.
Okay. My name is Sarah, and I'm a perfume vendor.
Oh, okay. Where are you based?
I'm currently at Oshobo, Ocean State.
Oh, okay. Awesome. Awesome. That's interesting. That's good
Yeah.
to know. All right. So, shall you check your DM? I already sent you something. So, without wasting too much time, um, yesterday was our opening day, and this training is a 5 day event, right? Which we started yesterday. Um, so Sarah, you can just mute your video. You can mute your video.
Okay. Okay.
Yes, thank you so much. All right. So as introduction is always a continuous process, it's very important to recognize the person that also joined us. So AY, can you just introduce yourself to us? You know, your name and what you do. AY, are you there?
GM, can you hear me, guys?
Yes, we can hear you loud and clear.
GM, it's nice to be here. I'm Ayobami Akinele. I'm the research analyst at Blockchain Labs. Nice to have you all here tonight.
All right, awesome. Thank you so much, AY. We are so happy to have you here as well. So, like I was saying, yesterday was day one of this 4 week 4 days training, and we covered a whole lot of things. We covered blockchain fundamentals, you know, what blockchain means, you know, how the blockchain ecosystem works, what happens behind the scene when people send transactions, when you send BTC, when you send Ethereum, when you send one asset from your wallet to your friend's wallet. What happens behind the scene? Okay. Who are the people that make sure that those transactions do not fail? Who are the people that ensures that you are getting your assets at the right time? And how blockchain is very, very transparent that you can see what is happening behind the scene. There is no middleman. You see what you pay for. You can track when you sent an asset and when the recipient is also supposed to receive the asset. So these are the things that we covered in day one session, and we've dropped a recap link. It's already in the Telegram community as well. So if you missed day one, you can always watch the YouTube video to catch up. And of course, this training also comes with certification. So, but there is a requirement for it. Before you can get your certificate, you must meet up with at least 80% attendance of this training. You must attend live sessions of this training. So it is important that you meet up with 80% attendance. And this is not just a training that's just about talk, talk, and talk. We walk you through practical demonstration of how these things work, so that after this training you can demonstrate to your friends. You can even tell your friends that I know how this thing works and I will show you how it works. You can do this with your phone or your laptop. So prepare your mind. We are going to be doing a lot of practical sessions tonight, and she is going to be walking us through a whole lot of interesting things how to use blockchain explorer, how to track transaction, what are the things to watch out for. I don't want to spill the beans, right? I know Sheyi is ready for us. He's ready to train us tonight. So, Sheyi, you have the floor. Thank you.
Yeah, thank you very much for that brief intro, and also like a recap as to like what we did yesterday. So basically, I'm sure Sarah and everyone we know why we are here, and is to learn about that house. Yeah, because about what blockchain is, which is the bedrock of the whole web system, right? So talks about Web3, inherent ecosystem, and from the beginning, today will be discussing about explaining the blockchain, right? Co-explorer, consensus algorithm, and how it works practically. So I'm trying to set up my slide. Just give me a moment. It doesn't come up on time. Share what I have from PDF. I think the network is okay. So once it's done, I'll try again so that I don't waste everyone's time here. Okay. Okay, let's get started and we can let me share my screen. So let me know if you can see my screen. Is my screen visible?
Your screen is not yet visible, but
If you
it's
let me
it's like it's
just
trying to come up.
react, give a top.
So
Okay.
yes, I can hear you, but your screen, your
Okay.
presenting screen,
Yeah,
your
yeah.
presentation screen is not
Okay.
showing yet. It's like it's popping up, it's loading. Okay.
Okay. Okay. Yeah, great. So we'll be starting with while I wait for the slideshow. Okay. Slideshow 2 is on now, so I'll just switch to that. Mhm. Network sometimes can be funny. Yeah. So we'll be discussing about exploring blockchain practically, right? So the first thing we'll be talking about is the consensus mechanism, right? So in the blockchain, when a transaction is being made on the blockchain, right? We need a mechanism to be able to verify the transaction, like to validate if the transaction is true or not, right? Yesterday, we talked about decentralization, that the blockchain is a decentralized ecosystem, which means that once a transaction is being made, everybody has access to view the transaction and look at the status of the transaction. And one of the things that make that possible is the consensus mechanism of that particular blockchain. So we have like different types of consensus mechanisms, right? But basically what consensus mechanism is all about is just how the different nodes on the blockchain how they agree to validate a particular transaction, like the method that they are using to validate a particular transaction, right? So let's say, for instance, we are 3 people, right? And okay, let's use traditionally now, for instance. If you transfer money to somebody, right? The way the person can validate to an extent that you have transferred the money to them is they will ask you sometimes to send a screenshot of the transaction on your bank app to them, right? And even after you send it to them, they also have to wait and see if it's going to reflect on their bank app or not, right? So that approach of them trying to confirm the transaction, that methodology is basically consensus algorithm on the blockchain, right? So the same thing that happens physically, that when you transfer money to somebody, you wait for confirmation to say, okay, an alert to confirm that the money has entered, or you send a screenshot to somebody to say that, oh, I've sent the money. This is a proof, right? The same thing happens too on the blockchain, right? But it doesn't happen manually, because we do our own manually. It kind of happens automatically, right? And it happens across different nodes, right? Because it happens across the different nodes. So there are different types of consensus algorithm mechanisms or algorithms that we have, right? And the reason for having this consensus algorithm is to ensure that there's security, there's decentralization, and there's trust, right? Because blockchain is a decentralized system. It means that if I send money from A to B now, so for instance, if I send money from my account to your account now, aside from the fact that I'm the one sending money to you, that transaction will also go to other people as well, right? So let's say, for instance, I send money to you. I can also snap my transaction and send it to another person, so that in case maybe you want to say that you did not see the money or something, that other person can stand in and say, oh, this person saw the money, right, as a witness, right? So the same thing happens to on the blockchain. Any transactions are propagated across what we call nodes on the system, and the way all those different nodes across the network, the way they confirm if that transaction is true or not, if the person did not send fake alert or not, the way everybody confirm it is by agreeing on a method, which is like the consensus algorithm, right? So we have different types of consensus algorithm. We have the proof of work, we have the proof of stake. These are like the 2 common consensus algorithms, right? So for the proof of work, the proof of work concept on the blockchain is in such a way whereby, okay, before explaining what proof of work is, let me just take a step back and explain like how transactions on the blockchain are, how they are propagated, and how they are validated or confirmed, right? So once a transaction is being sent on the blockchain, right? Maybe you're trying to send money to somebody. Once a transaction is being sent on the blockchain, it first of all goes to the mempool, right? Then from the mempool, there's something called mempool. Then from the mempool, we have what we call miners, or we have what we call miners. So that from the mempool, the miners pick transactions from the mempool, and transactions go from the mempool to the block, right? Then on a particular block, miners perform complex mathematical puzzles to try to solve or validate that the transaction in that block in a particular block is valid, right? So they can be like 10, 15 different transactions in a block, and a particular miner can be working on one or two of those transactions to confirm that this transaction is correct, right? So the work of the miners, what they are doing is their machine is running some kind of calculation just to confirm that, okay, this person that is sending the money has the money to send, right? And this money that this person is sending is going to this person's account, right? So that's what mining is all about. People that are mining are people that are helping the blockchain to confirm transactions or to validate transactions, right? So, and that's where the proof of work concept comes in, right? So a particular concept, one of the consensus algorithm that we have is proof of work, in the sense that in that consensus algorithm, there needs to be miners, right? People that are ready to help the network to validate the transaction, if the transaction is true, if it's valid or is invalid, right? So they are the one that would validate the transaction before the transaction is now being added or confirmed on the blockchain, right? So for proof of work, it says how it works. Miners compete to solve complex mathematical puzzles. So the way it works is that once there's a transaction, there are multiple miners, there are different miners trying to help confirm that transaction. And the fastest person to confirm the transaction gets the block rewards and gets the access to put that transaction on the blockchain, right? So for you to be a miner, miners, they need a lot of compute and compute power and energy. Basically, they need computers, supercomputers, or computers that would be able to help them confirm the transaction, because it's not something that you can be doing manually. It has to be automated, right? So they have machines that help confirm the transactions, and those machines, they take up a lot of compute power. So it's not like regular laptops, and also, so it's like there are some like big machines that help to make sure that that's possible, right? So the blockchains that use this proof of work as a way of validating transaction on their blockchain is Bitcoin. So Bitcoin uses proof of work. Ethereum was also using it around in the early days before 2020, before the transition to proof of stake. We'll be talking about proof of stake later on. So there are like pros and cons of using this proof of work consensus, right? So for just like the method that I am using as an example, which is that, okay, if you send money to somebody, you can screenshot the debit and alert and send it to the person. If you do that method, you know that people can do fake alerts or people edit alerts. So that method, the drawback of using that method is that they can be fake. Somebody can send you like a fake screenshot. The same thing too happens for proof of work or the blockchain too, right? The way they confirm transactions, there's like advantages and disadvantages to it. There are pros and cons. So for the pros of proof of work, is highly secured. So it means that if I put out a transaction now and say I transfer money from person A to person B, there are a lot of people that are confirming the transaction at the same time. And even after the transaction has been confirmed by one person, has been validated by one person, other people need to still confirm it again for it to be added to the blockchain. So it's not easily compromised, right? You can't compromise it, because if the person that validates the transaction validates wrongly, there are other people to cross-check to see if the transaction is valid or not, right? Then it's resistant to Sybil attacks. So for these Sybil attacks, it basically means that somebody is trying to somebody is trying to pose as multiple validators or multiple miners just to try to game the system, right? So there's no way that this is going to be possible, because for you to be able to game the system, you need like 50% control. Like you need to own like 50% mining compute power, and which is almost impossible to have, right? Then the drawback, the cons is that it's energy intensive, which means that like the machines that help confirm the transaction, they take up a lot of they consume a lot of energy and all. Then we also have like slower transaction speed. The transactions on proof of work ecosystem, especially Bitcoin, is usually slower, right? Because a lot of people or a lot of miners need to confirm the transaction before it's actually added to the block as a valid transaction. So it means that, let's say, for instance, maybe like 1,000, 1,500 people needs to confirm a transaction. Excuse me. So that makes it takes more time for a transaction to go. So if somebody is sending Bitcoin to you, for example, now, or if somebody wants to send Bitcoin to you, for example, now, the process, just have it in mind that the process it takes for your Bitcoin to get from your own account to the person account, it goes through a proof of work consensus mechanism. And after it is validated, a miner has picked it up and validated the transaction. It also needs to be confirmed by multiple people. So it means that, for instance, your transaction can take up to 2 to 3 minutes, 5 minutes, 10 minutes, depending on the congestion on the network, right? So that's it about proof of work. So for proof of stake, right, we have another consensus algorithm, which is proof of stake, right? So proof of stake is another method that some blockchains use to confirm transactions or validate transactions. So we've talked about the first one, and we've talked about the pros and cons of the first one, which is proof of work, which is that, oh, it's secured, but it's slow, and it need multiple people and machines to help confirm the transaction. But for proof of stake, right, we have the way we confirm the transaction is basically through validators, right? So for proof of work, it's miners. Miners have the machine to validate. While for proof of stake, it is validators. So what do validators do in proof of stake? Validators are people or companies that are chosen, right, to help validate transactions. And for you to be a validator, you need to be able to stake a certain amount of the cryptocurrency you are validating. You need to be able to stake it and lock it up while you are still a validator, right? So it's just like the way we have I wanted to use like a traditional banking system, but I'm trying to look at it in a way that would favor, that would bring the points home. Okay, so let's use the traditional banking system too, for instance. So I don't know if you guys know that for you to be a tier one bank, which is like banks like Zenith and all, for you to be a tier one bank, you need to be registered with the CBN. That's one. And number two, you need to deposit a particular amount with the CBN, and it runs in millions of naira, right? So you depositing that money to CBN is a way to show or prove that, okay, let's say for one reason or the other, the bank goes bankrupt or something happens to the bank, right? CBN can take that money and settle the people that the customers of the bank, basically. So, and if there is any like discrepancy or anything, CBN has the right to take that money and send to the person. And that's why interbank transfers goes through the CBN, because CBN has every other bank money in their own bank, right? So basically, bank A can trust that bank B has money, because if I'm sending money from bank A and I'm saying I want to send 100,000, I'm a customer of bank A. Bank B does not know if that 100,000 is available or not, but they trust that the money is on CBN, right? So the same mechanism sort of to happens here on proof of stake, which means that for me to be a validator, to be validating transaction, I need to first of all take an amount. I need to first of all set up an amount of money in that cryptocurrency and lock it up, right? And I'll be the one validating transaction, right? So if a transaction comes in, I'll be the one, like it can randomly select any validator. And if I'm selected as a validator to validate that transaction, I'll basically validate it and say, okay, this transaction is valid. But if by one means or the other, if I'm wrong, right? Maybe, for instance, I validated a transaction of 1 million naira and the person sent 10,000 naira. If I'm wrong, right, I'm going to first of all reimburse. I'm going to reimburse, like the blockchain, the um, algorithm is going to take money from the money that I've locked up as a penalty fee for me, and they're also going to make sure that that transaction is balanced. So I'm basically going to pay the debt or the excess money that is left, right? So let me try and bring it home. For proof of work, right? After one person validates a transaction, multiple people also cross-check, make sure that this thing is this valid. Proof of stake, just one entity will validate the transaction. No other person is cross-checking. But if that person makes a mistake, right, that money that the person has locked up is what is going to be used to balance that transaction, right? So in both cases, for proof of work and proof of stake, there's what we call reward, right? So like, for instance, if you transfer money now with your traditional bank app, when you transfer the money, they remove charges, right? The same thing happens on the blockchain. When you make a transaction, there's charges that we call gas fee, right? And it's out of that charges that people that are validating the transactions get paid. So it's not like people are validating it for free. The miners are not doing it for free. They are getting paid a percentage of the transaction fee, right? The same thing too as a validator. For you to be a validator to earn, right, you have to drop you have to drop something substantial to enable you to validate transactions, right? And once you make mistake, like maybe once or twice, you'll be kicked out of the validators pool, right? So that's just like an overview of what proof of stake is and how it works, right? So uh, no mining is required, just validating and earning rewards, and it's more energy efficient and scalable in the sense that it doesn't need like multiple people to confirm a transaction. Once a validator confirms or verifies a transaction or validates a transaction, it goes straight to the blockchain. So this proof of stake is being used by a lot of blockchains. So Ethereum 2.0 is using it. We have Solana. Solana is using it. I don't know. Polkadot too is using it. So what are the pros and cons, right, of proof of stake? So for the pros, it's environmentally friendly. That means it doesn't take up much resources, energy resources, right? So it's environmental friendly because you'll not be burning a lot of fuel to or diesel machines to keep up or to keep running all these large machines for proof of work. Then it's faster and has cheaper transactions compared to proof of work. So what are the risks, right? So the risks is centralization. So like the wealthier users control more of the stake, which is very true, right? The reason why we don't have like a lot of banks is because the money to set up, the money you give CBN, all those licenses and all those things, they are like it's like a huge barrier. So it doesn't allow for a lot of people to come into the space. The same thing too as validators. You can't just wake up and say you want to be a validator. You need to have like a lot of money stacked up, right? So it's there's a risk that okay, only the rich people can be able to like access it, and in some algorithms, the more stake or the more money you have locked up, the more your chances of you validating a transaction. So even if you have money to even start, you might not even go far if you don't have a lot of money in your pool compared to others, right? Then there's complex slashing penalty for bad behavior. So there are a lot of things that comes into play when you are being slashed for bad behaviors, right? So because it's an algorithm that is running it, the algorithm can just flag you unnecessarily, right? You might not really know what you did exactly, right? So you can just get flagged, and before you know it, if it continues like that, you get kicked out of the system and you lose like a huge chunk of your money, right? So these are like the two basic ways that the blockchain used to verify transactions, right? To confirm that, okay, this person actually has this money that this person wants to send, and this person actually received the money and whatnot, right? So moving on, would be exploring how this thing works in real life. So I've been doing a lot of talking about proof of work, proof of stake, Bitcoin, Ethereum, Solana. We've been talking about all these buzzwords, all these different blockchains. So we'll be looking at examples of transactions and how these transactions work in real life, right? So we'll be starting with the proof of work. So for proof of work, we can go ahead and check the Bitcoin Explorer on. We'll be checking the Bitcoin Explorer. So I would open this now. Can you guys hear me? Just give a thumbs up if you're still following. Mm, okay. Yeah, thank you. For one reason or the other, I don't know. Why is mempool taking so long to load? I think it's the network. So we're doing some practicals to just show how these things work. I should have opened this a while ago. Let me just open Ethereum Explorer too. Tasker, just so that doesn't take our time. I don't know what's happening this night. The network is bad. So let's just give it a while to load. So the Bitcoin Explorer or an Explorer is where you go and check a particular transaction or confirm transactions. So for instance now, if you make a transfer on your bank app, the first place you go to check if the transaction went through or not is you go to your bank app. You go to the transactions on your bank app to check the transaction. So on the blockchain, the transaction is public. It's not only you send money to somebody or somebody send money to you. Anybody can see that transaction and see that, okay, this is the transaction as it be confirmed. Like, what stage is this transaction on currently? So that's what we are trying to look at now, right? let me just check if the I think it has fully loaded. So this is what the mempool blockchain explorer looks like. So this, for instance, this is what we call block on the blockchain, right? So like I said, a block consists of different transactions. So this block now has 6,789 transactions on it. And this is the blocks that are still on the mempool. They've not been added to the blockchain itself, right? So here you can see the transaction fees. Like the transaction fees it depends actually on the activity on the blockchain, but this is like an overview of what the transaction fees is, and this is the average transaction time. You know, we said that proof of stake, that is Bitcoin, it takes time for it to confirm a transaction, right? So currently, the transaction time is 9.5 minutes, right? So these are like the recent transactions that have been done by multiple people on the blockchain. So if you click on this particular transaction now, for instance, just let it load. Let's see. You know why the network is very terrible. So once this loads up, we'll be able to see like the details of the transaction, like who sent the money, how much was sent, and who is the person sending the money to, right? So one good thing about the blockchain is that this transaction is available publicly, right? So anybody can access it. It's not that if I send money to you now, if you do not see the money, you cannot track it, right? Because you don't have access to my bank app. But on the blockchain, every transaction is publicly accessible. So if I say I send money to you, I can just send you the transaction ID, which is this ID, and you just come, you paste it, and you yourself can look at the transaction and see, okay, this money has dropped or this money has not dropped. So that's basically how it is. I'm trying to see other interesting stuff, but for one reason or the other, they are not loading. But I'll be sharing this link, or we'll be sharing this link too, so that you can also, in your spare time or after the call, you can check it out and see how these things work too, basically. So if you notice here, you see like transactions are coming in. See, it's changing. Transactions are coming in. People are transacting. Right? Transactions are coming in on Bitcoin. This person sent $300. This person sent I can't even keep up. Right? They are coming like every seconds. Thousands or hundreds of transactions are coming in. Right? So these are like the transactions coming in. I can click on any of them and check them and see what's up. So yes, so good. So this is the fee that was charged for this transaction. It's $0.44, right? 392 sats, which is Satoshi. Then the time is like less than 9 minutes. It took less than 9 minutes for this transaction to be confirmed, right? And this is like diagram flow of how the transaction went from point A to like the person that is supposed to receive the money, right? So these are also like ops around the transactions, people that are validating it and all. So this is basically what it looks like. So 5 minutes ago, this block was confirmed. There's a new block that is filling up as well, that is ready to be pushed to the blockchain. And these are the ones that are waiting, right? We still have all these ones now, they are yet to be confirmed. right? All these transactions here now, they are yet to be confirmed yet. So that's about Bitcoin and proof of work. So what was it? Okay, this is just statistics on the main. So because of quickly move to proof Ethereum, which is what I'm using Solana. I didn't shit. Maybe because I'm straight my face and also God have mercy. So moving on, let's check out proof of stake, how their transactions, where you can go and check your transactions, information about the transaction, how things work there. So this is Etherscan. You can check any transaction rate and come to transactions and see the latest transactions. This is loading. Okay, so for Ethereum in the last 24 hours, we've done like 1.6 million transactions, right? And we have like, these are like the pending transactions that we have 134,000. Then this is the fees. This is the average transaction fee, $0.5 for today in the past 24 hours. So if you notice, transactions are coming in. This one came in 15 seconds ago. There are a lot of transactions that came in 15 seconds ago, 15 seconds ago, 15 seconds ago. So transactions are always coming in on the blockchain. And once they come in, the validator will validate it. And once it's validated, bam, it is pushed to the blockchain, right? So this one is much more faster than proof of stake that they have to proof of work that they have to wait, right, for transactions to be confirmed. This one is almost instant. So for this particular transaction now, for instance, if we can check this particular transaction and see what this transaction is about, right, we can see the transaction hash, which is the transaction reference. Then we can see who is sending the money from, right? It's from Judah.net. To is where the money is going to and the value of the money. This person is sending 0.01 Ethereum and the transaction fee that was charged, the gas fee, and every other details. So let's say, for instance, now somebody sends you Ethereum. What you just need to do is you tell the person, send me the transaction ID. And once you get the transaction ID, you just paste it here. You just search for it here. And once you search for it here, it's going to give you all the details of the transaction. It's going to let you know if the transaction is successful or not, if it's failed, or there's any error or issue with it. Because there are sometimes that transactions fail, right? So you can easily check and tell the person, oh, this transaction is not successful. So that's like one of the benefits of the blockchain, and this is how most proof of stake. This is how their explorer is. So the explorer is where you come to confirm transactions. So because of time, we'll be moving fast. So we'll be checking proof of stake for Solana based ecosystem. So let's check Sol Explorer as well. So it's also going to look similar to Ethereum, right? Because they use almost the same consensus algorithm. So like you can see here, okay, this is just like an overview of Solana. right? So,
I don't think you're.
hello. Oh, my screen stopped sharing. Okay, okay.
Yeah.
Thank you for mentioning that. Sometimes Google Meets can be funny. All right. So this is Solana, the Solana Explorer. All right. So the same way, if there's a transaction, you come here and you paste in your transaction ID for you to see a particular transaction. But if not, you can, okay. But if not, you can check transactions. Hold on, let me show you some live transactions. Why is this in beta? Okay, this is live transaction starts. For transaction confirmation start visit. Okay, this one is for the validators, right? I will even prefer that you see this. The so scan is actually where we would also be seeing live transactions too. So let's just wait. Yeah. So if you notice, is also similar to Ethereum. These are like the latest transaction, and thank God, thankfully, we have an example of a transaction that probably failed, right? So see this red now signifies that there's something wrong with this particular transaction. So if somebody sends you money now, for instance, you can paste it here and confirm if the transaction is successful or not. And you can tell the person, oh, this transaction is not successful, it's successful. So as you can see, transactions are coming in. 34 seconds ago, a transaction came in, right? So these are like the TPS of the transactions, the average throughput of like some of the of most of the transactions that are being done. Yeah, so these are like the latest transactions. You can search for transactions here, and you can just look at the network, see the transactions that has been done on the network, the current epoch of Solana, and other informations too, right? So you can see it's somewhat similar to Ethereum too. So it's basically they basically both are proof of stake consensus. So we talked about validators, right? So this is just like an application to see Solana validators metrics and get to see the validators that we have around the world. So funny enough, I think we have just one validator in the whole of Africa, right? Um, these are validators around the world. These validators are people that are confirming transactions, right? That I mentioned earlier, right? So if you want to be part of the validators, you can sign up and drop and set up your money and also you stake your money in the stake pools for validators, and you also set up your software too for it, right? So I just said I should just segue into to just show you like practically what it, it means to be a validator, what it looks like, right? So these are like the different validators that Solana has. This is stake economy, this is G2, and the rest of them like that. So all these are validators, Mad Labs, and all. So they are like validators on Solana, right? So moving on. So I think that's the end, right? So it's been a roller coaster of network issues and all, but I think we've been able to um, glide through till the end of the slide. So I think now is time for you to ask question. If you have any question, you can ask now. Sarah. Um, okay.
Okay, I wanted to ask about that field and transaction.
Sorry,
So,
come
like,
again. I think that's
I said I wanted to ask about the field transaction.
okay. The failed transaction. Oh, okay, okay.
Yes.
Let me. Okay, go ahead.
Okay. So now, if the person confirm if the transaction, how it feels like, you said the thing is showing red already, which means the transaction was failed. So
Yes.
how um do we like notify them that it's failed? Are we not to notify them? I don't get.
Oh, okay. So, um, there are a lot of there are different reasons why a transaction can fail, right? So that failed transaction will just show you that okay, this transaction has failed, right? So the way it is that if I want to send money to you now, for instance, we have what we call crypto wallets, right? So it's just like bank apps too, where you um where you have access to your crypto, right? So if, for instance, me now, I send money on my app, on my crypto wallet to you, and that transaction, when I send the money, I sent you the transaction ID that, okay, confirm, I've sent the money, go and confirm it, right? The first place you go to is the Explorer. So when you go to the Explorer, you copy this thing and paste it there. When you now check, if you see that the transaction has failed, the person too will also see it on their own end. But you, as the receiver, you can see it too and tell them that, oh, this transaction is not successful. Check it and resend my money or resend the money. You understand? But for instance, now in normal banks or traditional banks, there's no way for you to know that the transaction has failed from my own side. You understand? So the only thing I have to show you is maybe screenshots, and I'll be telling you that I've sent the money now. See they've debited me. See the screenshots. Whereas they can reverse it back to the person. You understand? So if you trust the person or if you are fidgeting, for instance, if you are selling something now, you can give the person the item, right? And that way the person can scam you. But on the blockchain, if the person is saying they have sent it, they've debited them, you don't need to argue. You just take that transaction ID and go and put it on the Explorer and see it. And once you see it, you say, bros, this your transaction, no go see is failed. Check on your side. You understand? So the blockchain is transparent and decentralized, right? So that's why I'm saying that I'm happy that there is even a failed transaction, because since morning we've just been seeing successful, but they can be failed transactions. So let's say, for instance, you did not provide enough gas fee, and we'll still get to that, right? Your transaction can fail, right? It can bounce back because your gas fee is not sufficient for the traffic. You understand? Because you can set your gas fee, right? So if, for instance, the gas or the transaction fee that you're supposed to pay for a transfer is 5 naira, if you think that you are smart and you put 3 naira, your transaction can be rejected, right? So those are like some of the causes why people have failed transactions, right? So that's why I'm saying that one good thing about the Explorer is it allows you to see the status of a transaction, even if you are not the one that sent that transaction, or even if you are not the one that is sending the transaction. Like those transactions we check now, we are not the one. I did not send money to anybody. I did not know anybody, but everybody can see it. But one good thing is that we cannot know if it's Sarah or if it's Daily, because it's their wallet address that is showing, which is like a very long string. All right. So I cannot know who is sending, like the real person. I cannot know the real person. I can just know that, okay, this, like for instance, now if I go there and I'm seeing only account number, I cannot know the person that have the account. I can just see the account number. All right. That's the same way too on the blockchain. You can just see the wallet address, but we don't know who owns those transactions, but we can see it and say, okay, this person, this address send money to this address, wallet address, but we don't know who is sending the money, right? So that's one good thing about blockchain. It's transparent and it's secured. Transparent in the sense that anybody can see any transaction, but it's secured in the sense that nobody will know that it's you that sent the money or is another person that sent the money. It's only two of us that send the money to each other that would know, because obviously for me to send money to you, you most likely sent me your wallet address, which is like account number, right? So I can know and say, oh, see, this transaction did not go through. So I don't know if you understand.
Yes, I get you.
Oh, okay, thank you. Do you have
Awesome,
any?
awesome, awesome. That's a very good presentation. Thank you so much, Sheyi. We really appreciate, the walkthrough, you explaining what consensus mechanism means, and I remember that during our day one training, when we were discussing about benefit of blockchain, we also discussed the transparency, which makes it easier and better to track whatever happens on chain, which we cannot see in government establishments or in other financial space. So these are the benefits of blockchain, right? And then now that we understand what proof of stake means, I believe anytime we come across it online, we can comfortably discuss it at length that this is what proof of stake means. It's so interesting that Bitcoin being one of the, in fact, being the father of all the coins, I used to call Bitcoin the father of all the coins, is still maintaining that proof of work because its code is very strict and the entire Bitcoin developer team, they are not ready to switch from that. So there's still a lot of networks, but most of them it is either they are running proof of stake or they are running proof of work, and that is why almost all the Ethereum compatible chains that we know as layer 2s or layer 3 networks that are built on Ethereum also use proof of stake for their own tokens or whatever coins that they are creating. So thank you so much, Sheyi, for walking us through that. Then one more thing for Sarah is that tomorrow in our next session, day 3, we are going to be covering practical demonstration on how to create wallets, things to note when you are creating wallets, because unlike Web2, where if you lose access to your accounts, you can go to your bank, you download the application and put forget password. Okay, or you can even go to your bank if you forget the password and they will give you a new password to open your account. In Web3, it is very delicate. So that is why it is very important that you know what to do when you are creating wallets, because a simple mistake can make you lose assets worth millions. Okay, so and with this, we are wrapping up tonight's session. I don't know if anybody has any other question. All right. In the absence of no other question, please can we just, give a thumbs up to our trainer for tonight? Let's give a thumbs up. Let's give a reaction to our trainer for tonight. We appreciate that was a lovely session. Now if you follow through this class, you can 100%, 100%, 100% analyze blockchain transaction. You can track where money is coming from, where it is going, how much was sent, how much was the gas fee that was paid, how much did the miners that processed the transaction and validated the transaction actually got. Now you know what proof of stake and proof of work means. So this class is very essential. If you miss fundamental class, you would definitely have issues when you are going to advanced sections of blockchain technology. So ladies and gentlemen, with this we call it a wrap, and see you all tomorrow. And of course, this session is recorded and posted across on our YouTube page, so you can always visit it anytime if you have any question or you need clarification. And of course, lastly, make sure you give us a follow on all our social media and just search for Blockchain Labs on Twitter, on TikTok, on YouTube, on Instagram. So we appreciate you and thank you for joining once again. So have a lovely night rest, everyone. Bye bye.
So, sir,
Yeah, bye.
bye.